If you're looking for a solution that will build your testing scenario based on your OpenTelemetry traces, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on a given technology. Today's episode is part of the OpenTelemetry and SRE series where we already covered several episodes. So the introduction to OpenTelemetry, how to instrument your code, what is the OpenTelemetry operator, how to observe your Kubernetes cluster using OpenTelemetry, and more. Today, the episode will be focused on a solution allowing you to test your traces, and I'm referring to TraceTest. If you're enjoying today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We will start with a brief introduction, then we will explain the principle of TraceTest. We will study on how we could deploy TraceTest. We will look at the test definition file of TraceTest, and we also look at the value that TraceTest can bring to us. We will have a short interview of Ken Hamric, the founder of TraceTest.io, and as usual, we will jump into a tutorial. Building tests has always been a challenge because we always have one question in our mind: what test do I need to get a decent testing coverage? When building a new service, we can easily imagine building tests for each main service of our microservices. But even by doing this, are we sure to cover enough risks based on our test cases? What about existing application running in production? Well, for this, we need to analyze it. So we're going to utilize documentation, logs, database records, observability measurements stored in our observability solutions to understand what is often used by our users and what is critical to our business. If our application is not well documented, then the effort to walk through the code, the logs, could be time-consuming and make the testing approach significantly expensive.
Oh, okay.
The good news is that we now have a standard that is stable for traces that could help us to resolve our challenge. And I'm referring, of course, to OpenTelemetry. OpenTelemetry has the advantage of producing detailed traces on the actual flow of a given transaction within our architecture. So with all the collected traces, we could analyze, and at the end, we could increase our testing strategy. Of course, we have different types of tests that we want to run to validate our application. But for a topic where I'm a bit comfortable, performance, then I would try to group the traces to identify the main flow of spans produced in a given time. The objectives is to retrieve the most representative user journey to help me to design the right test cases. What would be awesome is to be able to produce Sankey graph out of our OpenTelemetry measurements. So for example, here is the Sankey graph. For the metrics coming out of our architecture from our ingress or service mesh, I can design the right throughput that needs to be added to our test to run a realistic test. So distributed traces, metrics, and logs is gold for us. In the episode introducing to OpenTelemetry, we explain that using OpenTelemetry requires to first instrument your code, validate the quality of your traces, and then consume the produced traces. When instrumenting your application with OpenTelemetry, you will define at one certain stage the sampling decision. The sampling decision will define the quantity of data that you would be producing and store in Observability backend. OpenTelemetry provides a couple of different samplers. We have the always on, so basically 100% of our measurement will be sent to the backend. We have always off, where nothing is basically sent to our backend. We have the parent-based. If the span has a trace ID, then it should be sampled. This is a perfect sampler when we applied to backend services. And last, we have the trace ID ratio based, where we define a percentage of spans that we would like to sample. Those sampler needs to be defined at the code level in our instrumentation library. There is also the options to define sampling decisions on the OpenTelemetry collector. In fact, there are two processors available. So we have the head-based sampling and the tail-based sampling. Head-based will sample our traces at the beginning of the funnel. It's the most common one, but we never know in advance if we are going to have an error in one of our backend services. Tail sampling is the opposite. It's waiting to get the full trace to make the decision. This could be an interesting sampling decision that will focus on slow transactions or even errors. When we are in dev or in testing environment, we obviously want to have as many details as possible to be able to test and troubleshoot quickly in case of an issue. Therefore, we should define a sampling decision to always on. In production, we will need to find the right sampling decision, giving us the right level of details for the right costs. Yes, of course. Remember, we will always pay for the storage of our data. Out of this testing strategy, traces could be a great source to help us build our test case. It's precisely what KubeShop tries to resolve with one of the solutions, TraceTest. KubeShop provides other interesting projects that you should also look at. So we have TestCube that bring your test part of the Kubernetes lifecycle, and there is Monolock that helps you to create and build your Kubernetes manifest files. TraceTest relies on traces to build a test case. Therefore, building a test case will require to, one, of course, install TraceTest in our environment, two, connect to a supported observability solution. TraceTest currently supports various solutions, so it supports Jaeger, Tempo, OpenSearch, and SignalFx. The project, in fact, has a current issue open to make our life easier. Here is the link to the GitHub issue. TraceTest should, in the future, receive span directly from the OpenTelemetry collector, where TraceTest will provide one processor, the TraceTest processor, that will filter out all the span except the one generated by TraceTest. One exporter to send the TraceTest span to TraceTest. This means that we could create a dedicated collector pipeline for TraceTest without impacting or generating noise into our observability backends. The connection with our tracing backend is crucial to allow TraceTest to retrieve the spans related to a given test. TraceTest supports a variety of protocols. As of now, it supports HTTP and gRPC. To build a test case in TraceTest, you will first need to generate a trace running a test against your application. For that, you will generate a traffic using a supported protocol, so HTTP requests, GET, POST, gRPC requests, or you can also import a Postman collection. And soon, you will generate traffic by importing also OpenAPI specifications. Once the traffic is sent, TraceTest will retrieve the produced traces out of the generated traffic. With the help of the generated traffic, TraceTest allows you to select spans from our traces using a selector based on span attributes. You can then select a given span and create assertions. Once you have built the right set of assertions, your test case will be ready. TraceTest also comes with a command line tool that will connect to TraceTest server The CLI will help you to list the current tests, run a specific test. TraceTest has also an API allowing you to create tests, run tests, collect results, and more. At the end, TraceTest has all the components to automate the execution of TraceTest. TraceTest provide a Helm chart installing all the required components. The TraceTest server provides the UI, the API, and all the features required to build and run tests with TraceTest. TraceTest is composed of one application pod having the web UI, the OpenTelemtry Trace ingest API, and the API layer. We have a PostgreSQL pod to store all the data related to TraceTest, and it comes also with a config map to store all the configuration of TraceTest. So you will have the configuration of the type of telemetry exporter, so Jaeger, Tempo, and the other, the database connections, and more. It comes also with an ingress role, if you enable it, to expose the TraceTest server out of your cluster. If you don't want to use Helm, TraceTest also provide a bash scripts to deploy the various components of TraceTest. Last, the TraceTest CLI can be also installed in various ways, so apt, yum for Linux environments, homebrew for Mac, and traditional exe files for Windows. In the future, the CLI will also have an option to deploy TraceTest directly in your environment. Building all our tests from the UI make it very simple, but sometimes we also want to have a code or text version of the test to be able to store our test close to our releases repository. For that, TraceTest has a test definition file that could be generated with our preferred test editor or by exporting an existing test case directly from the UI. A test definition file has three main parts, so the test information, the triggering transaction, and the assertion. The test information is currently limited to the test name. Trigger will define how to send the actual traffic, so it could be through an HTTP, so with the method, the URL, the headers, the payload, and so on. Also the authentication, if it's required, so basic and the others. Or if it could be also just simply RPC requests. The test definition file will also map the lists of assertions that we would like to apply on the generated trace to validate our test. To create an assertion, you need to specify the selector that helps us to filter on the span attributes of a given trace. The selector is there to precise where a given check would be applied. You will create assertion with the help of the selector and create on conditions based on information available on the span attributes. So for example, if I want to validate the hipster shop, the request where I'm adding a product in the cart, so I can build the following test definition file. So you can see here, I'm sending a post request to the /cart, I'm putting some payload and so on. And here at the bottom, I also precise the selector, specifying that I'm selecting a specific span of my trace, and I'm putting the assertion where HTTP status code equal to 200. It means that if we define standards on the definition of the span attributes, then our application will generate span attributes in the top, of course, of the semantic conventions of OpenTelemetry. We can create very complex roles. Just to remind, OpenTelemetry creates span attributes respecting a semantic convention. So example, http.status.code is a standard span attribute. And there are many semantics to store the HTTP method, the HTTP endpoint, and even more. In fact, each technology has its own semantic convention. So here is a link to these existent semantic conventions. So how do you get the test results out of TraceTest? The test result will be, of course, available in the UI of TraceTest. But TraceTest server provides an API helping us to generate a JUnit report out of our test, generate a JSON payload with the results of a specific test. Of course, we could also retrieve the test results using the TraceTest CLI. The beauty of having tools like TraceTest is that it brings testing into another dimension. When we usually build our test, we make an action and we validate the output of the actions. When we test a service, we send a request and we check that the content of the response is aligned with our requirements. If we test a web UI, we interact with a web page and then we check if the response is correct. But we have no way of validating that all the various components involved in the transactions are working like expected. With TraceTest, we can now send a request and check the entire chains of calls. We can now build a test validating the response of our call, but even more, we can check that all the various spans are generated, that all the various components are being called, and so on. For me, that's a huge help for our functional and non-functional tests. You can also imagine building synthetic tests using TraceTest to validate that all the components are responding by looking at the generated spans. The other advantage that I see is related to observability. So we deploy an observability solution, we produce measurements, we process those measurements, and then we push them to an observability solution. But how can we validate that our measurements are good enough for production usage? Do we have all the details required to understand precisely what is currently happening in our environments? Remember, our produced measurements are aimed to help us to troubleshoot a production situation. TraceTests give us the ability to define a test case, validating a baseline based on traces. We can then add this test in our CI/CD process to validate that the level of details is always as expected. I think that TraceTest is the one of the first solution relying on traces to build test cases, but I'm convinced that more and more testing solutions will utilize observability signals to increase the efficiency of our tests. In order to get more details on TraceTest and get some product updates, let's call Ken Hamric, founder of TraceTest.io and other solutions like cross-browsertesting.com and Homes by Owner. Hi Ken, how are you?
Hey Henry, how are you doing? I'm doing great.
I'm good, thanks. I'm creating, in fact, an episode on TraceTest. I have introduced the concept of TraceTest by explaining the principle, how to deploy it, introduce the test definition files, and also the value of TraceTest. I have tons of questions related to the future of TraceTest, but before we jump to the questions related to TraceTest, could you briefly introduce yourself?
Yeah, Ken Hamric, live in Memphis, Tennessee, home of Elvis. Been doing technology since, did punch cards back in '82 and started with the web in '94, writing SIGI bin programs. So I've kind of grew up with the web development wise. And worked at Oracle, started a couple of startups. Last one, which had about 4,500 customers around the world, was cross-browsertesting.com, which was pretty cool business. And now here doing TraceTest, which I'm excited about.
Before talking about product updates, I want to know the story behind TraceTest. There is always a story behind a project. What are the reasons that has made you decide to build TraceTest?
I've been in testing since 2008 with cross-browser testing. Cross-browser testing, we had a ton of different devices. We had racks filled with phones. If you were to open them up, you'd see a row of phones, a row of phones, a row of iPads, a row of Androids. We had Mac Minis. You'd open up other cabinets, there'd be Mac Mini, Mac Mini. So we had a lot of different languages because you can't deal with all those different devices and VMware, et cetera, with the same language. So we were passing calls from system to system to system. Tracing it was a nightmare. We started probably 2016 timeframe. We moved to the Elk Stack. We put like magic tokens in so we could parse the logs and try to get for one transaction, here's what occurred. But it was not perfect. OpenTelemetry tracing was the solution that we did not have, and we needed it. In looking at OpenTelemetry tracing, coming from a testing background, I looked at it, I was like, when you're trying to write a test, you want to ask a bunch of questions. What happened here? What happened here? I need to check here. OpenTelemetry gives you all that information at a trace. So it seemed obvious to me. You should be able to interrogate the trace to get the answers about what actually occurred.
You are in fact the first testing solution that utilize OpenTelemetry data, and that is awesome. Do you have any news, product updates to share?
Next week, we're going to release version 0.7, which really excited about, particularly from a workflow point of view. We've divided into what we're calling the triple T. You set up a trigger, you work on your trace, and then you set up your tests. And we've got it aligned with those buttons across the top. We think it fits the workflow of developing a system. You hit an endpoint with API, you're looking at the response, and then you want to look at your instrumentation, you want to look at the trace, and then you want to build tests on top of it. And the second part of the release next week is we've made the install super easy. You install our CLI tool, and then you do a trace tests install, and it will guide you through the steps of installing either on Docker or on Kubernetes. So those are the two big parts of it. After that, we're going to work on chaining of tests. So we're going to introduce variables into the system so we can handle, you'll be able to set your environment. I'm in prod, I'm in test, I'm in dev. You'll be able to chain tests together and set up transactions to say, hey, I want to create an order, and then I want to do a get against the order. And you'll be able to pass the order ID in a variable from one test to another test. So that's going to be a huge release. We use trace tests ourselves to test trace tests, and in the process of doing that, we were having to pass lots of variables. And without the capability in the tool, we were having to do a lot of scripting to get the JSON response from one call, from one test, and move it to another. So we're adding that as part of the tool.
When we build our test case, we currently use selector based on span attributes, and we can create assertions on the information available on the span attributes. Have you considered to extend it to events and bagage?
Yeah, we haven't talked about having selectors based on the data that's in events. That could be interesting. We could definitely do it, but we've not talked about that piece. We definitely need to add to the system the ability to set attributes, or to set, we're calling them test specs now, but to set a test spec that says we expect this event to be in a span and the characteristics we expect to see. So that will be added. So we don't have it on the short term in the 1 month time frame, but
you're currently relying on OpenTelemetry Traces, but now that metrics is stable, our community will use OpenTelemetry metrics to produce metrics from their code. Are you planning to support OpenTelemetry metrics where we can validate our code that, for example, it's still producing the right metrics with the right format between several releases?
Yeah, a couple answers on that. We have some capability in the system now for looking at a specific metric, which is time. So we have the ability to put in things to say, for example, you can do a wildcard assertion or test spec to say all my database operations should happen in less than 50 milliseconds. And if you've got 30 database calls in that one span, in that one trace, it will trigger. It'll say, hey, this one took too long, which I think is a good thing. It's good capability. We're going to look at metrics probably next year as far as the official OpenTelemetry metrics and how to correlate test runs with what metrics were at that time. But it's not an area we've focused a lot on yet. We're just trying to get the nuts and bolts of doing trace testing well and covering that space well.
Currently, to build tests, you need to trigger a request or a gRPC test or a Postman collections and more. You mentioned that you will be able to create workflow of requests. Are you planning to create integrations with browser-based testing solutions, for example, like Selenium?
Yeah, absolutely. We've been been playing a little bit with the browser-based tracing. So, the traces that start in the browser and flow through the system. We're big Cypress users. We use it to test trace tests. So having Cypress or Selenium as a trigger for a test just makes tons of sense. And that's something you'll see. When we built the trigger concept in trace tests, we did it as an extensible framework. So we can add multiple different trigger types. We've got like 4 right now, and we're going to be adding those over time. But the browser-based ones make tons of sense.
Lots of testing tools are trying to provide features helping us to measure our test coverage based on our current test cases. In TraceTest, you have the test case based on a set of traces. Have you already imagined to also analyze the traces generated in production for a given application and compare it with the one defined in TraceTest to provide a sort of testing coverage?
I don't think it's something we've talked much about yet. I think, we were crawling 3 months ago, and now we're standing and walking. And that sounds a lot like sprinting and high jumps. So we'll get there. And I think we're going to get there based on how we're driven by the public. So as people are using the system and they're giving us feedback, if that's something they're interested in. One thing I think we have talked about is helping you improve the quality of your observability, and particularly making the traces great. So we want to be able to suggest if you're in the coding process and you're instrumenting your tool, we want to be able to give you suggestions, say, hey, this is a database span, but you don't have the query. Do you think you should add it? And we've talked about scoring from that point of view of how good of a job have you done instrumenting the flow. And these are some spots you could work on to improve that.
I covered most of the question. Thanks for your time, and thanks for providing TraceTest to our community. I'm convinced that it will change the future testing tools. Before we end the interview, do you have any events where you are going to be present so our community can follow you?
I'm flying out to Dublin tomorrow. So we're going to be at the Open Source Summit in Dublin, and we're doing a presentation on how testability drives observability. So excited about that. If anybody's at the conference, please attend. It'd be great. We're going to be at KubeCon. We're going to have a booth at KubeCon. I don't think we're presenting. But also looking forward to that. And both events, I'm looking forward to talking to people that are using OpenTelemetry in their systems and talk about what their problems are, what they'd like to see us put into the tool, et cetera.
All right, so let's meet in Detroit
for
KubeCon North America. Enjoy your day. Talk to you soon. Bye.
Thank you. Thanks, Hendrix.
In this tutorial, we would create a test using TraceTest. We would need for that, of course, a Kubernetes cluster, the Nginx ingress controller exposing our application, the Shop, the Prometheus stack, so the Prometheus operator with Grafana, and a couple of exporters. We will deploy Tempo as a trace backend. We will also deploy the OpenTelemetry operator to help us to deploy various OpenTelemetry collector, and a version of the online boutique fully instrumented. In this demo, we will try to build a test and make assertions on a specific spans. And then we will create a test definition file and use the CLI to trigger our tests.
Like every tutorial delivered by Is It Observable, there is always a GitHub repository. We are looking at the moment at the repository related to our episode, which is TraceTest. So there are a couple of requirements, so let's go very quickly on this one so we can move on. So make sure you got a Kubernetes cluster, of course, deploy the ingress controller in the proper namespace, and you need to get the IP address of the ingress, because we will obviously build 2 ingress rules, one for the application, so the Shop, and one for the Grafana to expose the Grafana dashboards. We are going to deploy Prometheus like usual, because here we're integrating with Tempo, and we're going to use the Kube Prometheus stack that will deploy everything. Similar to the other episode, we use K6 to generate traffic in the background, and K6 utilize one of the features, there's an output plugin of K6 using one of the features of Prometheus called a remote writer. That's why we need to enable it. So get the Prometheus objects to configure Prometheus and add the enable feature remote writer receiver. Once it's been done, then make sure to save the Prometheus service name. This will be required in our deployment of the Hipster shop. In fact, for the K6 job, because K6 is running through a cron job. We will deploy Tempo, because TraceTest has several tracing backend supported, so Jaeger, Tempo, and the others. But here, today, we're going to utilize Tempo. So here, there is a Helm command that will basically configure a couple of things with from our environment. So the Prometheus URL, we're going to put some service monitor to collect the metrics from Tempo as well, and so on. Something which is important is Tempo by default, the monolith deployment of Tempo doesn't have the gRPC interface enabled, so you have to edit the config map once it's been deployed and add the gRPC listen port, so 9095. And once we have added that in a config map, of course, we will have to also adjust the definition of the Tempo service to also add the new port 9095 to expose the gRPC interface of Tempo. So that will allow us to do some queries. In fact, not us, but at least TraceTest will be able to interact with that. So once you have done this piece, make sure to restart all the pods of the Tempo, so they will pick up the new configuration with this new gRPC port. To manage to collect the traces from the application, we're going to use the OpenTelemetry operator. So make sure to deploy this. That it requires for this the cert manager, and then we have, before we go to the deployment of TraceTest, which is going to be next step, we need to configure the collector. So we have a couple of pipelines pre-configured there. Those pipelines are pretty much obvious. I can show you very briefly. There's two pipelines as usual, one from the pod level, so injected as a sidecar, and the other one as an OpenTelemetry daemon set. So the sidecar will just be basically retrieving the telemetry data locally and push it to the daemon set. And the daemon set pipeline is very, very simple. The daemon set pipeline I can show you briefly. It's basically receiving traces and metrics, adding the Kubernetes attributes. It's always good to have extra dimensions. And as an exporter, we use simply the OTLP. In fact, Tempo use the OTLP endpoint. So we're going to export to that endpoint, and that will be simply our pipeline. So deploy, make the changes on those collector with the right address for Tempo and the others, and then you could deploy the daemon set first, and the sidecar container collector will be deployed within the Hipster shop namespace. So next step will be deploying Hipster shop. So we will deploy first the sidecar container. So then it exists, and we have the Kubernetes manifest, which is there. And by the way, in the manifest, we have added the annotation to precise on the few deployments that we need that sidecar container. So what are you going to get out of this this requirement? So let's have a look first at the pods running in the default namespace. So as you can see, we have various trace test collectors. So those are the various daemon set collector deployed with the OpenTelemetry operator. We have the various components that comes with the Prometheus operator, so the exporters, Grafana, and others. Then let's have a look at Tempo. Here we have Tempo running, and with only one pod because it's the monolith deployment. But if we look at the SVC, we can see that now we also have the port 9095 exposed, which is not necessarily the case if you deploy it with the monolith deployment. make sure to create a namespace for TraceTest, add this Helm chart repo, and we're going to simply apply this command here. Very simple. That basically connects to the tempo endpoint, that also configure the various ingress rules to expose TraceTest. Let's apply this in our cluster. All right, so now we have a URL for our ingress. Let's check it out if it's working. And we come to the UI of TraceTest. So at the moment, there's nothing much because we have created no test at all. Going to create a new test from the UI. And like described in the previous section, we have different way of creating tests by sending an HTTP request, a Postman collection, and so on. In our case, it's a pure HTTP call, so I'm going to do this. And here, I'm going to first look at the online. Then, of course, we precise the URL. So here, this is my URL for my environment. I have no headers to place, nothing. So we can just going to create it. So the first thing that TraceTest is doing, it's basically sending the traffic to the application that we have here. So the Heaps shop. As you can see, after the execution of the tests, the TraceTest show you the actual generated different spans that has been generated. So we have get currency, we have the product catalog. So we have a couple of different spans available, and from there we'll be able to create our test. So we can basically say that, for example, here we have this. We can see the metadata related to this span here. So here it's a gRPC request. And so we can create an assertion. So here I can select this piece here. By doing this, it will create a selector on the spans. And then I will be able to create assertions. So here I can see that the assertion has been placed. The filter to select the right spans has been in place. And then we'll be able to say, for example, that, we can see all the various span attributes available, and TraceTest, because TraceTest generates the first span, it calculates the duration, the type, and so on, the span count. So it's add extra information on top of the produced spans. So here, let's say that we want to make an assertion, say that the duration needs to be less or equal to the measured response time. So here we had a response times about 40. Okay, let's push this one. Then we have this one, which is our front end, our call. So this slash. So here you can see the list. We can select this one. So we're going to create an assertion on this one. And we're going to say, for example, that we want in the response body contains. So here we can do some stuff. As you can see, we have the TraceTest response body. So we can basically say that we want to make sure, for example, that we have a section with so we can take this one, for example, say that we want to have our response containing this piece. So now we're adding this piece. So now we have two checks available, one on the get list product to figure out the time, one on the front, and also we have a couple of other spans here which is the currency service. So we may need also assertion. So you can see that we have a couple of things here available, and you can basically from there look at the metadata and create the right assertions on top of that. Now, once we have done our test, we can publish the changes. So let's run this new test now that has with few assertions, and we could basically upgrade this test by adding more or less assertions, by adding more or less. I can also count, for example, the number of spans that I need in certain layers. So you have a lot of options to build the test case that you need. As you can see, it's working perfectly. If you go back to the menu, you will see all the test results for this particular test case. So we have the two tests. We have the one with we have two assertions, one And then we had a new one with more spans generated. So you can see that this rule, one of the rules that has been applied is not correct. So I need to update this one, especially on the response times. So I may change here. You can see that we were expecting a few milliseconds. So we could basically update this one. So let me change one of the assertions, especially the one with the response times, and put this one to, let's say, less than 10 milliseconds. All right, and save. And of course, we need to publish this one again. And we're going to run it. So here we were looking for a specific, and this one we are looking for. Oh, again, this one has been an error on this one. And now we can see that everything is green. So I can publish this one and I can rerun the test again. So in this time we had everything goes well, 3 checks, 3 passed, 0 failed. So you can basically update your test definition to make sure that at least your test is robust enough. Make sure to deploy the TraceTest CLI. I already have it. So if I do TraceTest here, you can see that it's already deployed. You will have to do a configure. So here, mine is not configure, so I need to configure one. So I'm going to do configure. So there are 2 things. Once you have a test running here, you can do here the test definition, and this will basically bring you to this file, which is the test definition file for the test that we just created a few minutes ago. So we can add this one, or also have another one that I created on the /cart, which is in the repo, on the TraceTest repo, that has a few spans related to check the response times on a few spans, to check that a couple of things are available in the response, and so on and so forth. To run test run, and then you can precise the file. So in my case, this is the one. And if I do just TraceTest run the TraceTest definition file that we just saw, it's going to basically send this test to TraceTest, run it similar to what we had in the UI, and apply the various assertions to that. So, which means we can automate using any automation tool that we want, our preferred one, and we get something. So here it seems that we have an error related to our test. So it seems we have a few things that was working on a few of the traces. But now if you want, because it's been executed to TraceTest, if I go back to TraceTest now, as you can see now, we have the hipster shop cart. So I can check it out. And I can see we have 1 passed and 3 failed. So if I have a fail, I can still look at the test that I have executed from a TraceTest perspective and see what was wrong or not.
That's it for today's episode related to TraceTest. TraceTest is a really interesting solution helping us to build our test cases based on OpenTelemetry Traces. It opens doors for the testing community, I think, to build functional and non-functional test cases to validate that our application is responding, but also that the backend is behaving like expected. I also see the value of using TraceTest for synthetic monitoring, because we can check more than just the UI, so it all could be very useful for us in the future. So if you enjoyed today's content, don't forget to like and subscribe to the channel, and see you soon for another episode. Bye.